Hi everyone, I thought I would make a quick video on this interesting concept called transposition, which is used while solving equations. Those who learned mathematics in the British system, transposition is the technique heavily used during equation solving, and in American system, the technique that is used in solving equations, that's nothing but using the properties of equality. So let's first see how we use properties of equality while solving an equation. And let's take a very simple example. Suppose we have an equation like this, x plus 2 equals 5. And if we have to solve for x, then what do we do? Well, we have to isolate x. That means somehow we have to get rid of the positive 2 from the left hand side. And the best way to do that is subtracting 2 from both sides of the equation, or adding a negative 2 to the both sides of the equation, right? And when you do that, it's going to look like this. And if you think about it, we used a particular property of equality that says that when equal quantity is added or subtracted from both sides of an equation, then both sides remain equal. And that's exactly what we are doing here, that we are subtracting 2 from both sides of this equality, or you can think of it like adding a negative 2 on both sides of this equality. The equality still remains valid. And from here, we can say then, well, this positive 2 and negative 2, they will cancel each other, that will become 0. So we are going to be left with x on the left hand side, and then on the right hand side we will have 5 minus 2, that is equal to positive 3, and that is the answer here, right? And the way we did it, we actually used one of the properties of equality to solve this equation, right? Now let's talk about transposition. If we want to use the transposition technique, then how can this be solved? Well, let's write down the equation again. X plus 2 equals 5. And we want to transpose the positive 2 onto the other side of this equality. Why? Because we want to isolate x, because we want to find the value of x. So we have to isolate x, right? And then what do we do? Well, now we want to transpose this quantity right here, the positive 2, we want to transpose it to the other side of this equation. And how do we do that? Well, it's very simple. We can say, well, then x is equal to, we have nothing else left on the left hand side, right? We had x and a positive 2. Now we are transposing the positive 2 onto the other side, and then we can say, well, we already had a positive 5, and this positive 2 is coming here, and he will become a negative 2. And if you kind of compare with our previous method or previous technique, you will see that yes, the end result is essentially the same. X is actually 5 minus 2. And here, as we transposed the positive 2 from left hand side to the right hand side, we are pretty much getting the same result. So from here, we can say that x is definitely equal to positive 3. So this technique is called the transposition. What is the literal meaning of transposition? Well, it's like changing the position of a quantity from one side of an equation onto the other side of the equation. Now let's take another example. Say suppose we had an equation like this. Let's say x minus 2 is equal to 4. And from here, how do we solve it? Well, we have to isolate x. That means we have to somehow nullify the negative 2. So what is the best way of doing that? Well, we can then add a positive 2 on both sides of the equation using the property of equality. So then we are going to have x minus 2, and then I am adding a positive 2 on both sides of this equality. So you already had a 4 over here, and I am adding a positive 2. Now what happens? Well, this negative 2 and positive 2, they cancel each other, they become 0, and then now we only have x on the left hand side. That's exactly what we wanted. And on the right hand side, we have 4 plus 2, that is equal to 6. Similarly, let's try it using the transposition technique. So if we have x minus 2 equals 4, and we have to isolate x, that means we have to transpose this quantity right here. We have to transpose this quantity from left hand side to the right hand side. And if we do that, then what will happen? On the left hand side, we are going to be left with just the x, and then on the right hand side we already had a 4, so we are keeping that. And then this negative 2, which is being transposed onto the other side, it will become a positive 2. And now if you compare with our previous technique, in both the cases you will notice that the end result is kind of same. It's becoming 4 plus 2. So from here we can say, well, then definitely x is equal to 4 plus 2, which is equal to 6. So from these two examples, we see that the end result is pretty much same whether we use the property of equality or we use the technique of transposition. Now let's take a couple more examples. Next I am going to take an example of multiplication. Let's suppose we have 2 times x is equal to 10 and we have to solve for x, and if we have to use the property of equality, then we can divide both sides of this equation by a positive 2 because we have to isolate x, and there is a 2 multiplied with x. If we have to isolate x, then we can divide by 2, then left hand side will become just x. So let's do that. So 2 times x over 2, I'm dividing by 2 on the left hand side, and I'm going to do the same thing on the right hand side. And from here you can see that these two and these two 2's will cancel each other. They will become 1, meaning if we divide both the numerator and the denominator by 2, that is again another property of fraction. Using that property of fraction where we can divide both the numerator and the denominator by a non-zero number, then also the fraction remains same. So in this case, that's exactly what we are doing here. So that is how this 2 in the numerator and the 2 in the denominator will cancel each other. So now we are left with x on the left hand side, and then on the right hand side we have 10 over 2, that is 5. And let's try the same thing using the transposition technique. So we had 2 times x equals 10, and if we have to transpose this 2 onto the right hand side because we have to isolate x, then what we need to do? Well, it is going to look like this. We can say, well, then x is equal to 10 divided by, because 2 is in the multiplication form with x, that means 2 times x or x times 2 or 2 multiplied by x. So 2 is in the multiplication form, and when we transpose it, it will become division form like this. And we can say, well, then from here definitely x is equal to 5. 10 divided by 2, that is 5. So when we transpose something which is in the multiplication form on one side and we are transposing it to the other side, it will become division. And similarly, let's take an example of a division here. Let's suppose we have x over 5 is equal to 10, and if we have to isolate x, then somehow we have to get rid of the denominator, and the easiest way would be to multiply both sides of this equation by a positive 5. So let's do that, and if we multiply both sides, then x over 5 multiplied by 5 is equal to 10 multiplied by 5, and from here you see that the 5 in the numerator and the 5 in the denominator, they will cancel each other, they will become 1. Actually, the property that we are using here is a property of fraction. I have created a separate video on the property of equality and fraction. I have shared the link in the description, feel free to watch it. There I have explained in details like how the property of equality and fraction works. So in this case, you see the 5 and 5, they will cancel each other, and then we are now left with just the x on the left hand side. So we have x equals 10 multiplied by 5, that is 50. And if we had to use the transposition technique, then how is it going to work? Well, let's write it down here. So we have x over 5 is equal to 10, and because 5 is in the division form, this is actually like this, x divided by 5, right? X over 5 means x divided by 5. So essentially 5 is in the division form on the left hand side, and if we want to transpose that, if we want to transpose it to the right hand side, then it will become multiplication. So then on the left hand side we will be left with just the x, and then on the right hand side we already have 10, and this division 5 becomes multiplication of 5, and from here we can say then x is definitely equal to 10 times 5, that is 50. So as you can see, in both the cases we get the same result, it's just that two different techniques of doing it, right? So let's quickly summarize the properties of transposition. When a positive quantity is transposed, so let me make the quick notes right here like this. So when positive quantity is transposed onto the other side of an equality, then this should become a negative quantity. The same quantity, just the sign will reverse. Similarly, when a negative quantity is transposed, this becomes a positive quantity, right? And similarly, when a quantity which was in multiplication form on the left hand side is transposed onto the right hand side, it will become division form. And similarly, if we had a quantity in the division form on the left hand side, and if we transpose it to the other side of the equality, then this will become multiplication form. So this is the summary of how the sign is going to change when we transpose a term from one side of the equation to the other side. Transposition doesn't necessarily mean that we have to transpose from the left hand side to the right hand side of the equation. We can also transpose a term from the right hand side to the left hand side. So whichever way we transpose, we just have to make sure that we are reversing the sign. If the original term is a positive term, after transposition it will become negative. If the original term is a negative term, after transposition it will become positive. If the original term is in multiplication form, after transposition it will become division form. And if the original term is in division form, then after transposition it will become multiplication form. That's all we have to remember. I hope everything made sense. Thank you for watching. See you in the next video.